All right, so good morning, good afternoon, or good evening. My name is Dr. Franklin, and I'm an assistant professor here at Norfolk State University. Just wanted to provide you a brief video on looking up critical T's in a T distribution table. So that's what we have right now on the screen, the T distribution table. And the T distribution table is a lot like the unit normal table in that as a sample size increases, it approaches normality as if it's a normal distribution. Okay, but it's a T distribution and it's a little bit more flat, and it doesn't have a necessary peak like a unit normal table. Anyway, the reason why we're talking about this is because looking at this T distribution table and finding your critical T is extremely important as it pertains to accepting and rejecting your hypotheses. So you need to know what your critical T is based on the aspects of your research study or based on the problems that you're calculating in class. Okay, so again, this is a T distribution table. And let me just take a little bit of time and describe what we're looking at. Up here you see two different diagrams. So one says one tail and says that you have to decide either if it's right or left. If you're doing a research study, you'll decide if it's right or left, positive or negative, based on what the research literature says and what your hypothesis is. If you're doing a problem within the class, you'll decide if it's right or left, positive or negative, based on what your word problem is telling you to do. Okay, so you'll see directional indications like positive or negative, and you'll make sure that your T critical is negative or positive based on that. So as you can see in this body of scores, there's no negative scores. So it's up to you to apply your acumen to these T critical scores when it calls for it. Okay, and there's two tails as well. So you're looking in one tail, you decide right or left, and then there's two tails where when you're not sure where the difference is going to exist, and you're going to make sure that you're taking into consideration both of the tails. So the negative side of the tail as well as the positive side of the tail. Okay, so those are the diagrams, and that's what they mean. So you have at the very top this horizontal box right here. It says proportion in one tail. So it gives you the proportions located in one tail if you're doing a directional test or a one-tail test, and it gives you these different decimals. So there's 0.25, which is 25%. If you take that 2 decimal places to the right, give you 25%. That's 10%, 5%, 2.5%, and 1%. Okay. So all that'll be given to you in your problem. And if you're doing a research study, you'll have to make the decision as to how you go about setting your alpha level. Okay, and that'll be based on the practicality of your study and the potential impact that it could have on human beings' lives. There's proportion in two tails combined. So it gives you that as well. So it gives you 50%. 20%, 10%, 5%, 2%. Okay. Now, as it pertains to these horizontal bars, based on your example, you will choose one or the other. So there's two of these different headings at the top, and based on the type of study or example that you're working, you will select one or the other. So you're not going to select both. And once you select one, totally disregard the other. Okay, so if you're doing a directional test, you're going to want to go with proportion in one tail, and you're totally going to disregard proportion in two tails. Okay, if you're doing a two-tail test, you're going to go with these numbers down here, and you'll totally disregard everything up here. Okay. There is degrees of freedom running down this vertical bar to your left margin. Okay, and it goes from 1 to about 120, and when we get around what seems to be 30, we start hitting these very large jumps and these large spaces between these numbers, these large ranges. And there's a reason for that. Once you get up to a certain sample size, the proportions associated with the tails in the one-tailed test or two-tailed test become pretty consistent. Okay, so there's not marked changes. So researchers did that for a reason, because they didn't want you just tediously going through column after column trying to find specific percentages that may have been off by a decimal or so. Okay, so this is them trying to help you out. So if you get a sample size that's 35, I usually tell folks to round to 40. If you get something that's 45, I usually tell them to round to 40. If you get something that's like 65, round to 60, so on and so forth. So go with the number that's closest to your particular sample size, or in this case, actually degree of freedom. Okay. How do you go about using this table? Well, you need 3 pieces of information. One, you need to know if you're doing a one-tailed test or if you're doing a two-tailed test. Okay, is it a directional test or is it a non-directional test? Okay, so you need to make that decision. Okay, and once you make that decision, you go to that specific header. Okay, so let's say we were doing a two-tailed test. That's the test that we're going to go with. We're going to totally disregard the one-tailed portion of it. Okay, so we go to two-tailed. Next thing you're going to need to know is your alpha level, which is usually given to you in decimal format. So you'll see an alpha level, and it'll be given to you whether it's 0.05, could be 0.02, but that alpha level will be given to you. So let's say that we were going with an alpha level of 0.05. Okay, so that's the column. This is the column that we'll be focusing on and going with. Okay, now the T critical that we select from this two-tailed alpha level of 0.05 column will be based upon whatever our degree of freedom is. Okay, so if you have a sample size of 11 scores, your degree of freedom is n minus 1, sample size minus 1, which would give you 10 for that particular example. So you have a sample size of 11, your degree of freedom would be 10. So you go to 10. And then you could just go over like that to your particular column. And for the degree of freedom of 10, for a two-tailed test, 5% in the tail, the boundary marker would be 2.228. Okay, so let's backtrack. What did I do? First, I asked myself, is this a one-tailed test or is this a two-tailed test? What does one-tailed and two-tailed mean? Well, you got these diagrams up here to remind you. Okay, so one-tailed, we're just looking at proportion of one-tailed. Two-tailed, we're looking at both of the tails. Okay, so that's given to you in your problem. I decided that it was a proportion in two tails test. Okay, alpha level of 0.05 was given to me. Okay, so that decision was made. So from there, I took into consideration my sample size. So my sample size is 11. But over here, they're asking me for DF, or degrees of freedom. So I take that sample size of 11, calculate my degree of freedom, and that gives me 10. Okay. So take that 10 and I simply go over to the column that I will be utilizing for my particular study. That gives me 2.228. Okay. So let's just try another example. Okay, so let's say we have a one-tailed test, and the alpha level is 0.05, and the hypothesized direction is negative. Okay, and our sample size is 3. Okay, so let me repeat myself. Proportion in one tail, so it's a one-tailed test. The alpha level is 0.05, and our sample size is 3. And the hypothesized direction is negative. What will be my T critical for a study? Okay, so Give you a little bit of time to work through it. Hopefully you did. Hopefully you're there. If not, you may want to pause it here because I'm going to move forward. So we got proportion and one tail. That's what we're going with. We got 0.05. Our sample size was 3, but we need our degree of freedom, right? So that's 2. 3 minus 1 is 2. We go over to our column that we need, and we got 2.920. So that's our T critical. Now, I told you that the hypothesized direction was negative. So even though you got a 2.920 within this table, it's important for you to know that this T critical also needs to be negative. So you just simply add a negative mark to this numeric. Why? Because the hypothesized direction is negative. So it's not positive, but it's negative. It's on that side. So this table is going to give you the absolute value, but when it pertains to a one-tailed test, you have to ask yourself, is it positive or negative? And then from there, either add a negative sign or just leave it off and keep it positive based on the hypothesized direction. Okay? So your T critical for a one-tailed test, 0.05, sample size of 3, would be this 2.920, and it would indeed be negative. Now, in the event that you calculated for your T a positive 3, that number exceeds the absolute value of 2.920, so it is out in the tails, but it's out in the opposite direction. So this negative 2.920 is actually over here. The calculated T that you got exceeds it, but it's over here. So as your research hypothesis is laid out, you wouldn't be able to accept it, but you could say that the test was significant, just not in the proposed direction, okay, and elaborate on that. So let's do one more just for the road. You got a two-tailed test. Alpha is 0.20, and your sample size is 4. Two-tailed test. Alpha is 0.20, and your sample size is 4. Okay, I'll give you a little bit of time to do that. And hopefully you found it. So we got proportion and two-tailed. It's a two-tailed test. Two tails, looking for differences that could be on the negative side as well as the positive side. So it's two-tailed. Alpha level is 0.20, right, or 20%. We have a sample size of 4, but the degree of freedom is 3, right? 4 minus 1 gives us 3. So we go over, and our critical T for this example is positive or negative 1.638. So why did I say positive or negative? Because we're taking into consideration that the difference may be in this tail on the negative side, as well as it may be in this tail on the positive side. Okay. So I hope that this was helpful, and it helps you be able to understand how to go about calculating, well, actually how to go about finding your critical T. Excuse me. Let me know if you have any questions. Let me know what you think. And thanks for watching. Bye.